Hi everyone! Welcome again to my channel, Math is Fun channel, where you can learn a lot of things in mathematics and you will be able to appreciate the beauty of mathematics. So before anything else, before you watch the video, please click subscribe. But again, before you subscribe, rather, watch the video first before you subscribe so that it will not be in spam, or I will not be in spam, or your subscribes will not be in spam. So please watch the video, subscribe. In subscribe button, kindly click the yellow bell button so that you will be able to um, what we call that, you will be updated in all new videos that will be uploaded in my channel. You want to learn a lot? Then subscribe my channel, share my channel, and click like after watching the video if you love it. Even if you don't like it, just joking. Okay, I would like to shout out all of the students out there who are listening. Hi everyone. I hope this channel is very helpful to in your classes in math. uh and this channel will also be happen to me. Why is it's like i'm I'm stuck. So again, those who are watching, please subscribe this channel and please watch it first before you subscribe, and kindly share it to your friends. And I hope this channel is very helpful for you to understand your lessons in mathematics, especially those who are doing a modular approach, okay? And also even in the online classes. So stay put, listen, and have fun. Have a great day, everyone. So let's now start with our discussion this in this video. So we will just, talk about the operations on radical expressions. Have you familiar about the word operations? Yes, you do, because you are doing that one. You were doing that one since you were in elementary or during your elementary days, but not in radicals. Okay. So normal numbers, we have operations. And in operations, we all know that there is always, or there are rules that we have to follow. Same with the operations on radical expression. So in the operation on radical expression, we are following some rules or properties. What are these rules? So the rules are for multiplication and for division. Let's start our operations on radical expression in multiplication and division. Later on will be addition and subtraction. So the rules for or properties that we need to follow in multiplication and division on radical expression. For multiplication, this is the rule. When you multiply square root of A times square root of B, the answer, or that is equal to square root of A times B. I want you to remember the rule. Wow, I really love the noise outside. Very motivating, encouraging. Okay, go on. Let's continue. Again, the multiplication rule or property for a radical expression is square root of A times square root of B. Then we have it, that is equal to square root of A times B, as you can see on the screen. For the division, we have square root of A over square root of B. That gives us square root of A over B. So in short, they are just the same form. So the form of this can be written, or this form rather, can be written in this form. That's why it's equal. So this form can be written in this form. So these are the properties that we need to remember in multiplication and division of radical expression. So I hope everybody will be able to memorize this one, because it's just so easy to memorize. And I hope everybody will do the same thing. Now, okay, in division rather, I forgot to remind you, your B may not be equal to 0. Take down note of that. Another rules for multiplications and divisions, we in cube root, we have the cube root of A times the cube root of B can be written as cube root of A times B. And for the division property for cube roots, we have the cube root of A times the over the cube root of B is equal to the cube root of A over B. So please have or pay attention on that rule. So again, your B may not be equal to 0 in your division property, because if that will be equal to 0, then everything will be undefined. That's why it states there that B must not be equal to 0. Okay, let's have an example. For multiplication, we have square root of 3 times square root of 3, as you can see. Then we have it square root of, sorry, again, square root of 3 times square root of 3. Applying the rule for multiplication, we have square root of 3 times 3. Then the 3 times 3 is 9. Then we have it square root of 9, which gives us 3. Again, you have two answers in here. It could be positive and negative 3. But I want you to answer or give me the answer, the principal square root in this given situation. So let's have the division or do the division. Square root of 96 over square root of 6. That gives us square root of 96 over 6, which gives us 16. Then the square root of 16 is 4. And that's how we follow the rule for the division of a radical. So I hope everybody got it correctly. Okay? So let's have another example for the cube root. The cube root of 5 times the cube root of 16, that gives us, applying the rule for the cube root for under multiplication, we have the cube root of 5 times 16, which is 80. Then again, how do we evaluate or simplify this one? Look for two factors of 80. That gives us, one of its factor must be a perfect cube. So we have it 8 times 10. So 8, separate them, applying the rule for multiplication, then the cube root of 3, of 8 rather, and then the cube root of 10. So that gives us the cube root of 3, which is 2. Multiply it to the cube root of 10. That's why our answer is 2 cube root of 10. So I hope everybody got it correctly. Another thing also, for division, same process. Applying the rule, you can have it 27 over 50. Divide it, that gives us 54. Again, 54 is not a perfect cube, so we will look for a perfect cube, factors of 54, two factors, and make sure that one of its factor is a perfect cube. So we have 27 and 2. Since 27 is a perfect cube, so these are the factors that we have for this 54 or cube root of 54. So separate them by applying the multiplication rule for radicals. So the cube root of 27, just separate this one, these two factors. Cube root of 27, then times cube root of 2. So cube root of 27 is a perfect cube, that gives us 3. And then just copy cube root of 2. So the answer is 3 cube root of 2. Easy, right? Very easy. So now let's proceed to the next example. Why is it there a lot of noise outside? Maybe today is an happy day because there are a lot of noisy things out there. So roots and radicals, under the roots and radicals or operations and radicals, we also have, if we have rules for addition, for multiplication and division, we also have rules for getting or simplifying the square roots or cube roots of radical expressions. And now our next lesson will be about the rules for adding or subtracting square roots or the cube roots. After we do the we did the rather or we discussed the division and multiplication rules of radicals, then radical expressions, then our main focus in this slide will be about addition and subtraction of radical expressions. So let's try to get to know how to add or subtract square roots or cube roots. Ready? I hope everybody's ready. So first thing that we're going to do is simplify each radical. So again, the first step to add or to subtract square roots or cube roots or radical expressions is to simplify first each radical. Again, say with me, simplify. So simplify each radical. The next is you can now add or subtract the like radicals by adding their coefficients, and you will just copy the radicals. the radical term. So again, yeah, two radicals are like, so again, as I have said, what are the steps in subtracting or adding square roots or cube roots? The first step, you have to simplify. Again, simplify each radical. Oh, I love the theme song or the music out there. So, simplify each radical first before you add or subtract. And in adding or subtracting of radicals, make sure you will add, or you can only add or subtract or combine the radicals having like or same radicals. So what if they are not like radicals? Then you cannot combine them. You cannot perform addition or subtraction of radicals. And in adding or subtracting, you can only touch the coefficients. You cannot touch or move the radical term. You will just copy it. Again, you will only add or subtract in the coefficients of a radical expression or term. You can only do that one when the radicals are like radicals. So what is like, or what are like radicals? So two radicals are considered like if they have the same expression under the radical symbol. What do you mean by that, sir? They must have the same expression under the radical, same index and same radicand. Again, you can only, what I mean is two radicals are considered like radicals if and only if they have the same index and same radicands. Again, same indices and same radicands rather. So take down note of that. So let's have an example so that you will be able to understand what I am trying to say and apply the concepts or steps. Example, 3 square root of 6 plus 4 square root of 6. What's the first step? Simplify. Can you simplify it, the radicals? Square root of 6, you don't need to simplify them. The next step is you have to consider if they are like radicals. Are they like radicals? Check their, what are the two conditions for like radicals? Same indices and same radicands. Same index, yes, index rather, 2. So index here is 2, correct, check the same. Same radicand, 6, 6, check. Meaning to say, they are like radicals. So if they are like radicals, then we can just combine their coefficients and we will just copy the radical term or their radicals. So 3 plus 4 is equal to 7. Then copy the radical. They're like radicals, which is square root of 6. Let's see if our answer is correct. Very good. Our answer is correct. What about this one? 2 and cube root of 11 minus 6, the cube root of 11. How do we do that? So how do you do that one? Okay, again, they are checked if they have the same indices. Yes, they have. They're in cubes, in cube rather. They're radicands. They have the same radicands, 11. So we can just combine their coefficients. 2 minus 6. 2 minus 6 is negative 4. And then cube root of 11. Look at the same answer. I hope everybody got the same answer. So I'll just clean this one first. Now, let's proceed to another example. Square root of 12 plus 5 square root of 3. Look at their radicals, square root of 12 and square root of 3. Are they the same? Are they like radicals? No. Why? Because it's 12 and 3, right? They have the same indices, but they don't have the same radicands. So what will we do? We simplify. Again, we simplify this time. We can apply the first step. Step 1, we simplify 12 so that they will have the same radicand with 3. So 4 times 3, simplify for 12. That's why we have it there. 4 times 3, then we have 5 square root of 3. Then square root of 4 is 2. Then square root of 3 plus 5 square root of 3. So this expression becomes like radicals. Square root of 3, square root of 3. Then just add their uh, their coefficients, 2 plus 5, 7, then copy the radicand. The radicals rather. They're like radicals, which is 7 square root of 3. Easy, right? Very easy. I hope everybody can follow it. And next, another example is this one. Negative 3 plus 3, the cube root of 40 minus 3, minus cube root of 135 plus 7. So how do we solve that one? Okay, first thing that we're going to do, as I have said a while ago, we have to check if they have the same radicals. They don't have the same radicals. As you can see, it's very pretty obvious. So what will we do next is we're going to simplify it. How to simplify again? 40, find factors of 40 that make sure that one of its factors rather is a perfect cube. We have 8 and 5. Same with 135, 27 and 5. Then get the cube root of 8. That gives us 2. Then 2 cube root of 5. Then another here, 27, as you can see. Uh, sorry, 27, the cube root of 27 is 3. Then we have it 3, negative 3 cube root of 5 plus 7. So we already have the same radicals. This one, 2 cube root of 5 and negative 3 cube root of 5. So I have to clear this one. So now we can just combine like terms, negative 3 and 7. So that is considered 7 minus 3. That gives us 4. Then this one, since they are like radicals, so subtract 2 and 3. So 2 minus 3 is negative 1. Then copy the cube root of 5. So negative 1 cube root of 5, or you can write it as 4 minus the cube root of 5. So I hope you have the same answer and you got the concept. That's just too easy. Do not make simple things complicated. Always make complicated things simple in math. That's why it will help us to love mathematics. Okay? So I hope you are still there listening. Okay. Our next topic in the next video rather will be about rationalizing radicals and its conjugates. So I hope you'll be able to watch that the next video that I will be uploading in my channel. So thank you so much for subscribing and thank you so much for watching until the end of this video. I hope that before you subscribe, I want you to please watch it first so that it will not be placed into spam, or your subscribes will not be in spam, or will not be spammed rather. So I hope everybody will watch this video before you subscribe, and please 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 click subscribe and click the share button so that you can share it to your friends in Twitter, in Facebook, and add in any other social media, so that you can help people who are struggling in mathematics to learn it more and even to appreciate the beauty of mathematics. That math is not a difficult subject, but it's easy, fun, and interesting to. So thank you so much for listening. Have a good day and have a Kit Kat. Again, this is Alistair Apale, alias Emma Watson. Thank you for listening, everyone.